This is the 2014 question 8 worth 45 marks. To go to 25 mark earlier in the paper, 70 out of 300, which is 23% of this paper, was just probability. So blood test. This is a blood test, and in 0.3% of the population, these people have a disease, and that's that there. A test developed to detect disease gives a false positive in 4% of tests. Don't see any 4%, and a false negative in 1% of tests, which is this 1% here. So we're given these two on the table, and we're asked to fill in the rest of the tree diagram. So we know that each branch of the tree adds up to 1. This becomes a really simple question. If you don't know that, you might be staring at it in disbelief. 997 and 3 is 1,000. 99 and 1 is 100. So we must have to have some information. This 4% they've given us must be to do with this branch here. And this 4% is false positives. So someone that does not have the disease, test positive, is a false positive in 4% of cases, making this 96%. So to get this box here, we just multiply the branches of the tree, 0.003 by 0.99, etc., all the way down. I'll just pause the recording and write the answers into the boxes so you don't have to listen to me doing multiplication. So these are our probabilities here. And part 2 asks, hence or otherwise, calculate the probability that a person selected at random from the population test positive. So here we go. Here's my two test positives. So we have 0.00297 plus 0.03988 equals 0.04285. Part 3. A person tests positive for the disease. What's the probability that they actually have the disease? So they test the positive, most probably they have. So this is conditional probability here. Conditional probability. So the probability they have the disease given they've tested positive. So the probability of, let's say it's A given B, is the probability of A intersection B over the probability of B, this conditional probability. So A intersection B, they have the disease. Well, they have, where did these two things cross over? They've tested positive and they have the disease. So that's this one here, the 0.00297, 0.00297, where the positives cross over, both positive and negative. And then on the bottom, we're going to have the probability of B that they've tested positive, which is actually the answer to the previous part. So it's basically the real positives out of the total of positives, 0.04285 gives me 0.0693, that's 6.93%. Now what's the question? A person tests positive. The probability that they have the disease is only 6.93%. This medical company have just been fired by the HSE. Is this part of the next question? The health authority is considering using a test on the general population with a view to the treatment of the disease. Based on your results, do you think the above test would be effective? Nope, definitely not. 6.93% positive. Crazy. No way. No way. Call the HSE straight away. And the second part of this, which is done in another video, but I'm going to leave it out of this because this is just for the guys revising their probability questions.